So hello, this is Zekeriya Aktürk, and I am going to make a video presentation in the context of the Advanced Biometric course seminars. In this video presentation, I aim to summarize the work of Gelman and Henning, titled Beyond Subjective and Objective in Statistics, which was published in the Journal of the Royal Statistical Society series. So first, a few words about the introduction section. It is really an excellent work, a masterwork, I would say a masterpiece of these authors, which received also very much comment from the statistical world, and was appreciated very well. So this is a very long paper, and I will first talk a little bit about the introduction section of the paper. This paper, what it is about, it's about the terms subjective and objective, how they are fitting in statistics, and is there a way to use some alternatives to subjective instead of sticking on these subjective and objective terms. Is there some other solution? So they re-evaluate the terms objective and subjective in data analysis and statistics, proposing to replace them with broader attributes such as transparency. So they have some few virtues which I will show you in the next slides: transparency, consensus, impartiality, awareness of multiple perspectives, and context dependence. This reformulation aims to guide statistical practitioners towards more effective use of diverse sources of information and greater acknowledgement of assumptions and goals. The paper presents examples from pharmacology, as at the end, the final sections, we have examples from pharmacology, election polling, and social economic stratification to illustrate their suggestion. I find this work highly relevant for health professionals, since I am a health professional too. Medical doctors are frequently accused of having no consensus on the diagnosis and treatment of different health conditions. So we are accused of being subjective. It is not easy for me as a medical doctor to make objective conclusions, to say this person has diabetes, this person is hypertensive, etc. These are simple examples. Of course, there are strict criteria today for defining diabetes and hypertension, but they also change with the time. So in many conditions, we have this problem also in the health professions. Guidelines are developed, of course, to achieve more uniform practices. However, even the guidelines differ from profession to profession and between countries. If you look at the European guideline for treating high cholesterol, that's different than the US guideline. If you look within Europe, within Germany, for example, to the Legam guideline, which is developed by GPs, and if you compare it with other guidelines, that has different aspects too. So it is highly relevant for me as a medical doctor. Okay, so I thought to this. Of course, I should mention also about the background of the authors. Both are renowned professors of statistics. Andrew Gelman is an American statistician, and professor of statistics and political science at Columbia University. He is a major contributor to statistical philosophy and methods, especially in Bayesian statistics and hierarchical methods. Christian Hennig is a German statistician. His work focuses on robust cluster analysis. Henning, besides, is the current editor-in-chief of the journal Statistica. So the word is, of course, important. Who says it makes it even more important. The paper discusses limitations of this binary classification of subjective and objective, of using these two concepts. The authors argue for a more nuanced understanding, proposing to replace they suggest proposing to replace this by some virtues. Now, a few words about the terms objective and subjective, because the authors have a section on this. The article explores the concepts of objectivity and subjectivity in statistical decision-making, emphasizing their role in the field of statistics. It criticizes the idea that some statistical methods claim to be completely objective by hiding user decisions behind algorithms, arguing that even seemingly one-click methods involve subjective choices. For many entities in daily life, for example, happiness, personality, human rights, there are no objective measures. That's what the authors claim. On the other hand, objectivity varies by observers. Thus, measurements may differ. The text highlights the need for judgment in statistical data analysis, and criticizes an over-reliance on the p-value, p below 0.05. This criterion is actually criticized also by many other statisticians and scientists. The following, I have a quotation from the text. It may be interpreted on one side that the current practice in statistics is pursuing for objectivity. On the other side, I had the feeling that it may be interpreted as statistics is difficult for unexperienced scientists, so there is no one-click statistics. Not everybody should have the courage to do statistics. And I quote, "Often these choices are hidden so that users of statistics, particularly those without specific background knowledge in statistics, expect that for their data analysis task, there is a unique, correct statistical method. This expectation is exploited by the marketing strategies for some data analysis software packages that suggest that the default analysis is only one click away." Unfortunately, I'm probably one of these persons who use these one-click statistics in his daily life. So let me continue to my next slide. Their core proposal, as I mentioned in the beginning, is their introduction of these virtues, which comes in the next slide. They propose a set of virtues to replace the subjective-objective dichotomy, aiming for a more nuanced approach that enhances clarity, consensus, and relevance in statistical practices. The authors advocate for moving beyond the binary of subjectivity and objectivity, suggesting a framework grounded in virtues like transparency, consensus, etc. So let me show you the virtues in one slide, the virtues the authors have mentioned. This list has 7 virtues, namely transparency, consensus, impartiality, correspondence to observable reality, awareness of multiple perspectives, awareness of context dependence, and investigation of stability. These virtues, including the ones in this list, serve as guidelines for more constructive statistical analysis, promoting a broader understanding beyond binary classification as subjective or objective. Each virtue serves a distinct purpose in the realm of statistics. Transparency ensures that all aspects of the statistical processes are openly communicated, allowing for critical evaluation and replication. Consensus highlights the importance of agreement among experts, fostering trust in statistical findings. Impartiality ensures that analyses are conducted without bias, focusing solely on the evidence at hand. Together, these virtues form a robust framework for ethical and reliable statistical practice. That's what the authors claim and suggest in their paper. So they define each virtue in more detail, which I'm not going to do here in their paper. And they also give details on how these virtues will contribute to statistical analysis. Then we have, as I mentioned in the introduction, we have applied examples. In pharmacology, election polling, socioeconomic stratification. By this way, they demonstrate the usability of these virtues in practice. So, first, some words about the use of this hierarchical Bayesian model in pharmacology. In pharmacology, the authors encountered difficulties in filtering a Bayesian model and found that a more informative prior was necessary, which they transparently justified. In election polling, they have also in election polling, non-random samples, using non-random samples in polling, and also the Bayesian approach here. Bayesian adjustment of survey data from non-random samples was used, grounded in prior information and hierarchical logistic regression. They also have a section on socioeconomic stratification, a case study on that. So here they emphasize the importance of choosing transformations and adjustments based on interpretative dissimilarity, context dependence, and multiple perspectives. Finally, they address the issue of testing of homogeneity against clustering, highlighting the challenge of finding meaningful clusters in data. So, the next section, as this numbers here in my slides represent the sections in the paper. So the next section is about moving beyond the traditional dichotomy of objective and subjective. They argue for a re-evaluation of the terms objective and subjective in statistical data. And I believe that's not only for statistics, the objective and subjective issues, as I said, they apply to many other disciplines, such as medicine. And there is a lot of philosophy also behind that. Proposing broader attributes such as transparency, consensus, etc. The authors aim to guide statistical practitioners towards more effective use of diverse sources of information and greater acknowledgement of assumptions and goals. The paper illustrates its argument with examples from pharmacology, election polling, and socioeconomic stratification. They challenge the dichotomy of objective and subjective and advocate for a more multifaceted approach to statistical analysis, emphasizing the virtues mentioned in the paper. So the virtues shall be substituted for the terms objective and subjective. That's the main point in this paper. They propose a list of virtues which shall be substituted for subjective and objective. And that's the claim of the authors, is that this will lead to a more transparent approach in statistical analysis. In exploring the foundations of statistics, it's essential to move beyond the simple binary of subjectivity and objectivity. In this section, number 5, this section delves into frequentist and Bayesian interpretations of probability, highlighting how our proposed these proposed virtues offer a richer framework for understanding these foundational approaches. They continue in the section 5 on the frequentist interpretation of probability. Here they give definitions and implications of frequentism. Frequentism, grounded in the concept of long-term frequencies, offers an observer-independent view of probability. This perspective, while often considered objective, necessitates idealizations that may not fully align with observable reality. The discussion around frequentism emphasizes the need for transparency in these idealizations and acknowledges the role of multiple perspectives in defining applicable experiments or reference sets, aligning with these virtues of objectivity and context dependence. So the frequentist approach, actually, they claim, aligns with virtues mentioned in the paper. We are still in the section 5, Bayesian perspectives. Bayesianism, with its subjectivist and objectivist branches, introduces probabilities as expressions of belief or logical analysis. Subjectivist Bayesianism emphasizes personal belief systems, while objectivist Bayesianism seeks a universal logic-based consensus. Both perspectives underscore the importance of transparency in prior selection and the relevance of consensus, illustrating the complexity of aligning with the virtues of statistical analysis. There's another important point mentioned in the paper, namely falsificationist Bayesianism. Sorry for my pronunciation. So they suggest a bridging view in this sense. Falsificationist Bayesianism emerges as a novel approach integrating Bayesian methodology with a frequentist interpretation of probability models as testable hypotheses. This perspective values the virtue of falsifiability, encouraging the empirical testing of models and promoting transparency and stability in statistical analysis. By acknowledging the iterative nature of scientific inquiry, falsificationist Bayesianism embraces the complexity and subjectivity inherent in statistical modeling. Now I would like to move to the discussion section of the paper. Adopting the proposed virtues in statistical practice encourages a departure from the subjective-objective dichotomy, promoting a more nuanced and inclusive approach. This shift has significant implications for how information is used and understood in statistics, urging professionals to embrace complexity, diversity, and diversity in their methodologies. By doing so, the statistical community can enhance the credibility, relevance, and impact of its analysis, benefiting both the field and society at large. Mathematically oriented statisticians often design methods with a focus on optimization criteria, but simulation studies with various choices reveal the subjective nature of these decisions. In the second section of the discussion, they delve into the connection between objectivity, subjectivity, and quantification in scientific measurement. This section critiques the belief that quantification ensures objectivity, emphasizing that choices in measurement procedures can limit observations and may not fully capture the entities being measured. The paper has also appendix sections, and in Appendix A, this section presents a rich exploration of objectivity as understood within the philosophy of science, introducing 4 fundamental senses outlined by McGill, namely absolute objectivity. So there's my cursor, there it is. Absolute objectivity, disciplinary objectivity, absolute objectivity which seeks to represent reality as it is, independent of any observer. Then disciplinary objectivity, focusing on the consensus among experts within a field, and procedural objectivity, defined by adherence to rules that transcend individual biases, and lastly, dialectical objectivity, which involves the active human effort to make phenomena communicable and measurable. These concepts are complemented by the ideal of observer impartiality and further distinctions like mechanical versus structural objectivity, the former aiming for unmanipulated representations of reality, and the latter emphasizing mathematical and logical structures as a response to the limitations of observation. However, the pursuit of objectivity has been met with skepticism and criticism, challenging its feasibility and desirability. Critics argue that the quest for absolute objectivity overlooks the inherent subjectivity of observation and the observer's influence. So there is an influence of the observer, which is not always possible to be objective. while others question the utility of objectivity as a scientific virtue altogether, suggesting it may serve more as a rhetorical tool than a meaningful goal. This discourse has stimulated the development of new scientific virtues and the re-evaluation of what constitutes good science. So, on one side, they criticize the current practice, and on the other, they try to make new suggestions. This paper has also, at the end, many 45 or over 40, I would say, comments and discussions made by important scientists from all over the world. Sorry, there is my slide again. Objectivity, and let me say a few words about these comments from other scientists. Commentators debate the author's view that the strict division between objectivity and subjectivity in statistics is unhelpful, and that both elements are present to varying degrees in all statistical analysis. Some discuss how this perspective aligns with or how it diverges from traditional views in statistics and the philosophy of science. The seven virtues proposed by Gelman and Henning are likely to be a major focus in our future practices. So they are by most of the authors, scientists who wrote a comment on that paper, these seven virtues are found novel and utilizable. And there are also comments on their future effect on statistics, namely evolving future research practices and probably introducing new methodologies. And this paper even could affect statistical education and introduce new concepts into the statistical education. Lastly, my conclusion from the paper, I see from that paper that there is, they try to open a new perspective in statistical approaches. So this is very important from my point of view, that they try to open, and they even do this, they are successful in that, I believe, to open a new perspective. This paper acknowledges the controversy in the use of objectivity and subjectivity and suggests a nuanced approach. The authors propose an active scientific realism perspective, focusing on supporting human actions rather than an ultimate quest for truth about objective reality. The tension between scientific consensus and diverse perspectives is recognized, and the importance of communication, transparency, and openness to new viewpoints is emphasized. Among original contributions of this paper to scientific literature are the seven virtues that meant to guide statisticians in navigating this tension. The shift towards recognizing a set of virtues rather than adhering to a binary classification can significantly impact the statistical community, fostering more open, nuanced, and effective approaches. So that's my conclusion from the paper. Of course, I'm happy to receive your comments and feedback. Here's my email address. I'm 50% employed at the University of Augsburg in the Institute of General Practice.